Alright, Mr. Bucko back with a couple more problems from your Chapter 8 practice test. On the screen here we have Algebra Skill 45b, where we have to find the distance between 2 points. And in order to find the distance between 2 points, you need the distance formula, which is this mess right here. Looks pretty complicated, but all that it is the Pythagorean theorem. May not believe me there, but it is exactly the same thing. Where the distance between any 2 points is the square root of the difference of the x values squared plus the difference of the y values squared. So I'm going to take the two x values, which is why there's a 1 and a 2, because there are 2 points here. There are 2 x values. I'm going to take the 2 x values and subtract them. And then I'm going to take the 2 y values and subtract them, and I'm going to square them. So by plugging these points in that we're given, we get this. The 2 x values are -4 and 6. So I'm going to do -4 minus 6, which is what I have right here. -4 minus 6, the difference of the x values. I'm going to square that. And I'm going to add that to the difference of the y values, which are 9 and -7. So I'm going to do 9 minus -7, the difference of the y values, and I'm going to square that. I can do what's inside the parentheses here. -4 minus 6 is -10. 9 minus -7 is 16. So all I've done is simplified what's inside the parentheses. -10 squared, which means -10 times -10, is positive 100. 16 squared is 256. So now I have the square root of 100 plus 256. 100 plus 256 is 356. And the distance between these 2 points will be the square root of 356. What's the square root of 356? I'm not sure. Where's the calculator? Turns out that it's 18.87. So the distance between these 2 points is 18.87. Same type of problem here where we have this picture here that Mr. Nelson drew from the solutions that are on Moodle as well. We have an airplane that's flying at an altitude of 10,000 feet, so that means that it's 10,000 feet from the ground. And the end of the runway is 30,000 feet away from a point on the ground, so we have this the end of the runway right here. We want to draw a picture of the situation and determine how far diagonally the airplane is from the end of the runway. So if this is the end of the runway and the plane is right here, 10,000 feet above the ground, how far is this distance here? And what we see here is a right triangle. So to find this distance of this right triangle, we are going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. In this case, we are missing c, the hypotenuse of this triangle. We don't know that distance, we're going to find it. So we're going to plug these values we know in to the formula. A squared plus b squared equals c squared. And I'm using d because that's what Mr. Nelson used in the picture here. We could easily use a c. It doesn't really matter what we use because it represents the distance from the plane to the end of the runway. Evaluating these squares, which I'm not going to do because they will be too big and they won't fit on the screen, what we end up getting is once we square 10,000 and we square 30,000, we end up with, let's see, this would be 1,000, million, 1 billion. So we have to take the square root of 1 billion because the square root of 1 billion is equal to d squared. Actually, the square root of 1 billion would be equal to d. So we're going to take the square root of 1 billion and find that that is approximately 31,623 feet. So that's what this distance is right here. It's 31,623 feet because the square root of 1 billion equals d, not d squared. This 2 should not be there.